In 2.3, we're going to be looking at domain and range. So on the front of your foldable, you're going to go ahead and fill in right there that when we're talking about domain, we are talking about the set of all possible input values of a function. So then let's go ahead and look at range. Range is going to be a set of all of the possible output values. So then when we look at those input values, when we open that flap again, we're going to just repeat that the domain is those set of input values. And then what I want to list under there is all the names or all the things that represent domain. We've written input a couple times, so we'll just re-put that. The domain are the x values of the function. And then the last name that also means domain is going to be independent variables. So I just want you to make sure you recognize that no matter what terminology the question uses, input, x values, independent variables, domain, that all those words mean the same thing. Okay? So when we are identifying domain and range, I've given us multiple different representations. Number one starts with ordered pairs. Once again, if domain is just the x values, then all we're doing to identify the domain in this set of ordered pairs is just listing the x values from each point. So we would just list 0, 1, 2, and 3. So when you are given a set of ordered pairs, it's very easy to list the domain and range. The second representation in number 2 that we see is a table. A table is also just a list of ordered pairs. So when we are listing the domains, once again, we're just listing those x values of each point. So the domain here of this function is 0, 4, 8, and 12. And I just use the little brackets to show that it's the set of those values. Number 3, when we're given a discrete graph like that, once again, we're just given a set of ordered pairs. So all we need to do for this domain, just like with the last 2, is list the x values of those points. So like if this point is -1, 1, 2, 3, -5, then I would list that x value as part of that domain. So that one has an x value of -1. This point has an x value of 0. This point has that x value of 1. And then this one has an x value of 2. This point has an x value of 3. And then that last point, its x value is 4. Right? 1, 2, 3, 4. Yeah, 4. 4. All right. So those first 3, really easy. You're just listing the x values for domain. Now when we get into these continuous graphs is where we start to be like, I'm not really sure, because we cannot just list them as like a discrete value. Because with this continuous graph, we're going to have x values all the way from this endpoint to this endpoint. And every value in between is part of our domain. So we can't sit there and list like -5, -4.9999999, -4.99998. Like we're not listing all of that. So instead, we're just going to write it as a compound inequality. So if our x's go from 1, 2, 3, 4, this has an x value of -5. So our x's will go all the way. -5 is going to be that minimum value. So this domain would be -5 is less than or equal to x, which is less than or equal to, we don't need to be on that right now, the maximum value, which has an x value of 3. So that means the domain is in between -5 and 3. So -5 is less than or equal to x, but x is less than or equal to the 3. Okay? So you're just looking, when you have a continuous graph like this, you're looking along this x-axis left to right. What's the minimum x value? What's the maximum x value? And then you're writing that as that compound inequality. Now, with number 5, this graph is a little different because we have arrows, which means this graph is going to continue to stretch towards positive infinity, but as it's stretching up towards positive infinity, it's also getting wider and wider and wider and wider and wider. Which means when I'm looking left and right to try to find a minimum and maximum x value, do I ever find a minimum or maximum x value? No. So that means the domain is going to be what? All real numbers are infinite. Yes. All real numbers, infinite, whatever. You could write it as an inequality from negative infinity all the way to positive infinity, but all real numbers there if it's going to continue to stretch left and right forever. Okay? All right. Done with domain. Now let's flip back open that flap. We will fill in this blank. Again, this is all your possible output values of the function. And then I have a typo. Sorry, team. This is supposed to be all other names for range. Obviously not domain again. All different names for range. 2 of which we've written a couple times. So you've got output and the y values. Your y values are also known as the dependent variables. Because what you get out of the function depends on what you put in. So your y values are going to be your dependent variables. All right, now, when we are listing the range for these first 3, it's going to be just as easy as the domain. Because when we have an ordered pair, when we're listing the range, all we're doing now is looking at the output values or those y values instead of the x's. So 3, 5, 7, 9. Then for number 7, when we're looking at our table, same thing. A table is just a list of ordered pairs. So when you are asked what is the range of the function, you are just listing those y values of each point. If you have a y value that repeats, you do not have to list it twice, like if it's not an actual. And then number 8, I gave you that discrete graph, but again, now we're doing the range, so now we're listing the y values of these points. So this was the point -1, 1, 2, 3, 4, -5. So we need to make sure we're listing the y values of those points. So that has a y value of -5. This point has a y value of -3, -1, 1. This has a y value of 3, and this point has a y value of 5.
You watched that movie, To Kill a Mockingbird?
Okay,
Yeah.
the last one with our continuous graph. Just like we did with the domain of the continuous graph, the range, when it's continuous, is also going to be written like an inequality. But this time, instead of looking along this x-axis and looking left to right, now we're looking up and down. So this graph has a minimum point and it has a maximum point. And this minimum point is not one of these endpoints. The lowest point on this graph is down here at this point. And this point has a y value of -5. So the lowest point is at -5, and then the highest point of our graph is up here at 1, 2, 3, at y equals 4. So be careful when you're given these continuous graphs, because again, the lowest point isn't always this end point that they give you. It's actually down here. So -5 is the least, that's our minimum, so we'll write that first, and that's less than or equal to, and then be careful because you need to put y, very good, because we're talking about range. But the y values are going to be less than or equal to that max, which is at 4. The other thing I'll warn you about, and you'll see during your practice, is that if these circles are closed, or if the dots on the point are open, then those would not be included. So instead of the less than or equal to sign, you would just put less than. Okay? And then our last one is our quadratic graph. This one is not all real numbers, because when we are looking along this y-axis, yes, it's going to continue to stretch up towards positive infinity, but it does not go all the way to negative infinity as far as the y values are concerned. The lowest point on this graph has a y value of -3. Then it can be anything higher than that, again, because it's going to continue to stretch to positive infinity. So that means this range are y values that are what? Greater than or equal to that -3. Okie dokie.